So in addition to using matrices for solving systems of equations, we can also use them for a variety of other applications, and we can perform arithmetic with them. We can add, subtract, and multiply them. So we are going to look at adding and subtracting them today. As a reminder, an m by n matrix is a matrix with m rows and n columns. And this is going to be very important notation, distinguishing rows from columns. The entry in the ith row and jth column is denoted by the symbol Aij. So when you see that symbol, they will give you the rows first always and columns second. Now a square matrix is a matrix with the same number of rows and columns. So you can have a 2 by 2 or a 3 by 3 or a 4 by 4 square matrix. We can also have a column matrix, which is a matrix made up of a single column, or a row matrix made up of a single row. And matrices are only equal. They're only considered to be equal if they have the exact same dimensions and every corresponding element are equal. So it's very rare to have completely equal matrices. They may have the same dimension, but if all of their entries are not exactly the same, then they would not be considered equal. So I've listed 4 different matrices, and we want to practice some of these definitions on them. So the first question says to give the dimension of each of the matrices above. So again, we have to make sure we say it in the order of rows by columns. In A, we have 1, 2, 3 rows and 1, 2 columns. So this is a 3 by 2. In B, we have 1, 2, 3, 4 rows and only a single column. So 4 by 1. C actually is a 1, 2, 3 by 1, 2, 3. So a 3 by 3. And D has a single row with 1, 2, 3, 4, 5 columns. So 1 by 5. Which of these matrices is a square matrix? Well, that would be matrix C. It's the only one with equal rows and columns, a 3 by 3. Which matrix is a row matrix? So the one with a single row is matrix D. The column matrix is matrix B, a single column. And now let's practice naming some elements. So notice these are for matrix C. Whenever you're working inside of a matrix, the capital letter will denote the name of the matrix, and then a lowercase letter will be talking about the elements inside of that matrix. So if I were talking about matrix A, I would use little a's here for elements. If I was talking about matrix B, I would be using lowercase b's. So these are lowercase c's. This says to go to matrix C and find the third row, second column, and tell me what entry is there. So that would be the 1, 2, third row. So it has to be in this row. And the second column. So let's say the second column is right here. So the entry in that position is 0.0. C1, 3 would be what's in the, I'm going to do different colors here, what's in the first row. Oops, I thought I was on my highlighter. So what's in my first row and my third column. So that one is the 1.0. So you do have to make sure you have row and column in the correct order, otherwise you'll pick out the incorrect elements. Okay, let's set up an application here. It says, consider the following matrix representing the output of Acrosonic, a loudspeaker system manufacturer. The company manufactures 4 different speaker systems at 3 separate locations. A 1-month output is described below. So what we've got across the top are our speaker models, A, B, C, and D model. And then we have 3 different locations as our rows, location 1, 2, and 3. So what this says here is find P, again, this is matrix big P, so we have little p, 2, 4, and give the contextual interpretation of that. So what element is in the second row, 4th column? So this would be my second row. This would be my 4th column. So there is my entry. So P24 is the entry 0. And what does that mean contextually here? So it looks like at location 2, they did not manufacture any Model D speakers this month. So something like that. For this month, there were no speaker D models made at location 2. Sorry about the color change there. That was a hand bump. Find the sum of the entries in row 1 and interpret that result. So row 1 is this row. If we find the sum, that would be what is 320 plus 280 plus 460 plus 280 again. So 1340, that would be the sum. And what does this stand for? Interpret that. Well, that is how many total speakers were made in location 1. For this particular month. Find the sum of the entries that make up column 4 and interpret that result. Okay, so column 4 would be this column. Find the sum there would be 280 plus 0 plus 880. So 1,160. And that would be that there were 1,160 Model Ds made in the last month, combining all of the different locations together.